This code imports a series of libraries including XGBoost, NumberPy, Pandas, and Plotly. It also installs the library strldecompose. It then defines various functions and sets default values, such as muting warnings and changing the background color for visualizations. Finally, it creates a template for charts to be displayed using Plotly. This code loads a dataset from the specified directory, filters the data to only include dates from 2010 or later, and then displays the first few rows of the dataset. This code creates a subplot with 2 rows and 1 column, and adds 2 trace elements to it, one for a stock's open, high, low, and close prices, and one for its volume. It then updates the layout to hide the range slider on the x-axis and shows the resulting plot. This code creates a copy of a data frame that contains 2 columns, date and close, sets the date column as the index, performs a decomposition on the data with a period of 365, and then plots the decomposition on a figure with custom size dimensions. This code adds several new columns to the data frame, each containing the mean of the close column for different time periods. It then creates a graph using this data, with each line representing one of the calculated means and the opacity set for the original close data. Finally, it displays the graph. This code calculates the relative strength index, RSI, for a given stock or financial instrument. The function relative_strength_IDX takes in a data frame of stock data and calculates the RSI using a default period of 14 days, unless specified otherwise. The RSI is then added as a new column RSI to the original data frame, and any missing values are filled with 0. The result is then plotted using the Plotly library and displayed as a line graph. This code calculates the exponential moving average (EMA) and moving average convergence divergence (MACD) indicators for a financial dataset and creates a visual representation of the data using a plot. This code creates a new column called close in the data frame (DF) and assigns the values from the close column, but shifted down by 1 row. This means that the value in the close column will be from the row below the original value. This code selects rows from the data frame starting from index 33 until the end and assigns it to the variable df. It also removes the last row of the data frame and updates the index based on the new length of the data frame. This code creates a dataset by splitting an existing dataset into 3 parts: training, validation, and test. The size of the test set and validation set are determined by the test_size and valid_size variables. The dataset is split at a certain index based on the size of the dataset multiplied by the test size or validation size. The training set consists of all data up to the validation split index. The validation set consists of data between the validation split index and the test split index, and the test set consists of all the data after the test split index. Finally, a plot is created using 3 different scatter objects, one for each dataset, and then displayed. This code drops the columns named date, volume, open, low, high, and openInt from 3 data frames named train_df, valid_df, and test_df. This code assigns values from the close column of a data frame to a variable called y_train, and assigns the remaining columns in the data frame to a variable called x_train. It repeats this process for 3 other data frames, valid_df, test_df, and train_df, and then calls the info function on the x_train variable. This code creates a dictionary of parameters for a machine learning model, sets up an evaluation set, creates a model using the XGBregressor class, and then uses gridsearch-CV to find the best combination of parameters for the model. It then prints the best parameters and the best validation score for the model. The code creates an XGBregressor model using the best parameters found by a classifier and fits it to the training data, using an evaluation set and disabling verbose output, measuring the time it takes to run. This code plots the importance of different features in a model. This code uses a trained model to predict outcomes for a given set of data. It then prints the first 5 actual outcomes from the test data, y_true, and the first 5 predicted outcomes, y_pred. This code prints the value of mean squared error calculated by using the function mean_squared_error on 2 input variables, y_test and y_pred. This code creates a plot with 2 subplots showing the predicted stock prices compared to the actual stock prices. The first subplot shows the predicted and actual prices for a specific date range, while the second subplot shows the predicted and actual prices for a different date range. The code uses the data from a data frame and a machine learning model to generate the predicted stock prices.